breaker is off. Check for power. No voltage with breaker off. Flip breaker on. Inside board. From this point on, we have no power. Our board is removed. We're going to set our meters to the ohm setting. We're going to check continuity at our fuse. Then we're going to check continuity across our core, across our board. Then we're going to move to the back prong. If you have continuity in all three places, your board is good. If no continuity at your fuse needs to be replaced. A blown fuse. On certain models, your capacitor may be located behind the magnetron and transformer. Capacitor is usually located in the right upper corner of the microwave. To check the high voltage capacitor, you must first remove the diode and lay it to the side, and then check your tag for your reading. This reading will be 0.9. To check your capacitor, you must put your meter on the megafarad reading, or the ohm, in this particular meter. One lead to one side, one lead to the other. 0.9 is a good capacitor. In order to check for a faulty diode, a diode allows power to only flow in one direction. So to check our diode, we need a 9-volt battery. We'll take our common lead of our meter, we're going to set to DC. 9-volt battery is DC. We're going to put that on your common on the ground. We'll put the diode on the power, and we're going to check for voltage. So we have 5.99 voltage on that side of our diode. Now we're going to take our diode and flip it completely around Stick it back to our battery and check for voltage again. You should have a very low reading. So we got 0.007. So this is a good diode. Power is only allowed to travel in one direction. Voltage capacitor. It's usually located at the bottom of your inside panel. Just got one screw to uninstall. Find our reading, which this particular capacitor is a 10 megafarad. To check our low voltage capacitor, we'll take our meter, put it to megafarads. Common lead to one side, power lead to the other. Hold it for a few seconds. 9.85. The door switches are located behind our panel. We'll remove our panel, located inside on the left. Your top, your middle, and your bottom. To check our door switches, we'll start with the top switch, also known as the door switch. There's a little peg you have to mash to uninstall the door switch. We'll take our multimeter, put it on our ohm setting of continuity, and without the button pressed, you should have no continuity. With the button pressed, it will have continuity. No continuity with the button up. Moving on to our monitoring switch, our middle switch. Uninstall the switch by pressing the button on the back. Take the switch out. With the button up, it should have continuity. Mash the button, it should not have continuity. Should have continuity with the button up. Moving on to our bottom switch, also known as our primary switch. We'll take and remove our switch. And with the button up, you should have no continuity. With the button down, you should have continuity. Button up, no continuity. If your microwave breaker is instantly tripping, always check your monitoring switch first. Locate your thermal fuses. Some models only have one thermal fuse. If you have a fan, you'll have a second thermal fuse. This thermal fuse should have continuity. This thermal fuse should not have continuity till it reaches a certain temperature. First, identify which thermal fuse you will be checking by locating the 0. Means that this thermal fuse should have continuity. Set your multimeter to your ohm setting and check for continuity. That means this thermal fuse is good. On some models where you have the ventilation fan, you'll have a second thermal fuse. Identify the number 70, means that your thermal fuse should have no continuity until the temperature reaches 133. We'll set our multimeter to our ohm setting and check for continuity. which we do not have. That thermal fuse is good. To check the magnetron, we first locate it. It'll be located near the center of your microwave. To check our thermal fuse on our magnetron, we'll put our multimeter back on our ohm setting and check for continuity, which we should have continuity. Check magnetron plug for damage. Normal wear and tear is to be expected. To check our magnetron, we must check for a ground. So we'll check to make sure we have a good ground. Move our positive lead to one side of our magnetron and we should get a reading. We have a 0.6. Up to a 1.0 is acceptable. Then we'll move our power lead over to the other side. We should have the 0.6. If you have continuity between either two plugs, your magnetron is bad. Your transformer will be located near the center of your microwave, close to your magnetron. In order to test our transformer, we first need to locate our 3 coils. Our bottom coil will be the primary coil. The top coil will be the secondary coil, and the middle coil will be our heater coil. We need to start with our primary. We'll start by taking our multimeter and turning it on our ohm settings. And we'll start by touching the 2 prongs together. You should get a reading of no more than 3.0. Then we'll take and make a ground on our unit. These are gel coated, so you need to scratch somewhere where you have a good ground. You'll apply your ground and check each prong for continuity. You should not have any continuity on these 2 prongs. Then we'll move to our heater coil, which is in the middle. Leaving our ground where it's at, we'll go to the heater coil and put our hot lead. We should have a reading. It should be no more than 150. No lower than 35. Then we'll take our secondary coil, checking each wire to your ground for continuity. Each prong should not have continuity. Then we'll move our ground up to our secondary coil and check across the plug for continuity. You should have continuity across the plug. You should have continuity across the secondary lead.
Testing the vent fan motor. Following our wiring harness that comes from the vent fan motor through into the microwave, we can see run and our start wire going to our capacitor. Following our blue wire through to our microwave to multiple points, we know that the blue wire is our common wire.
Testing our motor, we'll start with our blue wire to our yellow wire and get our reading. Connection number 2 will stay on our blue wire and move to our red wire. Get our reading, 60.6. And connection number 3, we'll go leave our red wire on and go from our red to our blue wire. Get our reading, 89.7. Middle.
Common to run plus common to start should equal very close to run to start. 29 plus 60 is 89. That means this motor tests good.
Testing our vent fan capacitor. Remove the wires. .87. It's a good capacitor. Checking your turntable motor. Start by making sure you have no obstruction, no damage to the rotator. Checking your turntable motor. Unplug your plug. Put your meter on ohms. You should get an ohm reading around 4 ohms. Anything astronomically lower or higher, this motor would be faulty. Check each lead to ground for continuity. If you have continuity on either leg, this motor is faulty. Checking your display panel. Is your display panel lit up? Is all your buttons functionable? Does your clock program? Checking your board. Always look for visual damage in your board. See there. Check for loose plugs, wires. Check for corrosion or oil and grease on your ribbon connectors. Make sure that's good and clean.